All these issues are visible in a process as simple as stuffing envelopes, but they are of real and much greater consequence in the work of every company, large or small. The small batch approach produces a niched product every few seconds, whereas the large batch approach must deliver all the products at once, at the end. Imagine what this might look like if the time horizon was hours, days, or weeks. What if it turns out that the customers have decided they don't want the product? Which process would allow a company to find this out sooner? Lean manufacturers discovered the Baini TS of small batches decades ago. In the post-World War II economy, Japanese car makers such as Toyota could not compete with huge American factories that used the latest mass production techniques. Following the intuitively efficient way of building, mass production factories built cars by using ever larger batch sizes. They would spend huge amounts of money buying machines that could produce car parts by the tens, hundreds, or thousands. By keeping those machines running at peak speed, they could drive down the unit cost of each part and produce cars that were incredibly inexpensive so long as they were completely uniform. The Japanese car market was far too small for companies such as Toyota to employ those economies of scale, thus, Japanese companies faced intense pressure from mass production. Also, in the war-ravaged Japanese economy, capital was not available for massive investments in large machines. It was against this backdrop that innovators such as Taiki Ono, Shigeo Shingo, and others found a way to succeed by using small batches. Instead of buying large specialized machines that could produce thousands of parts at a time, Toyota used smaller general-purpose machines that could produce a wide variety of parts in small batches. This required gearing out ways to reconfigure each machine rapidly to make the right part at the right time. By focusing on this change over time, Toyota was able to produce entire automobiles by using small batches throughout the process. This rapid changing of machines was no easy feat. As in any lean transformation, existing systems and tools often need to be reinvented to support working in smaller batches. Shigeo Shingo created the concept of SMED, single-minute exchange of die, in order to enable a smaller batch size of work in early Toyota factories. He was so relentless in rethinking the way machines were operated that he was able to reduce changeover times that previously took hours to less than 10 minutes. He did this, not by asking workers to work faster, but by reimagining and restructuring the work that needed to be done. Every investment in better tools and process had a corresponding Baini T in terms of shrinking the batch size of work. Because of its smaller batch size, Toyota was able to produce a much greater diversity of products. It was no longer necessary that each product be exactly the same to gain the economies of scale that powered mass production. Thus, Toyota could serve its smaller, more fragmented markets and still compete with the mass producers. Over time, that capability allowed Toyota to move producers. Over time, that capability allowed Toyota to move successfully into larger and larger markets until it became the world's largest automaker in 2008. The biggest advantage of working in small batches is that quality problems can be identified much sooner. This is the origin of Toyota's famous Andan cord, which allows any worker to ask for help as soon as they notice any problem, such as a defect in a physical part, stopping the entire production line if it cannot be corrected immediately. This is another very counterintuitive practice. An assembly line works best when it is functioning smoothly, rolling car after car. The end of the line. The Andan Cord can interrupt this careful 2OW as the line is halted repeatedly. However, the BANI, TS of, ending end, seeing problems faster, outweigh this cost. This process of continuously driving out defects has been a win-win for Toyota and its customers. It is the root cause of Toyota's historic high-quality ratings and low costs. Small batches in entrepreneurship. When I teach entrepreneurs this method, I often begin with stories about manufacturing. Before long, I can see the questioning looks. What does this have to do with my startup? The theory that is the foundation of Toyota's success can be used to dramatically improve the speed at which startups find validated learning. Toyota discovered that small batches made their factories more efficient. In contrast, in the lean startup the goal is not to produce more efficiently. It is to as quickly as possible learn how to build a sustainable business. Think back to the example of envelope stew, NG. What if it turns out that the customer doesn't want the product we're building? Although this is never good news for an entrepreneur, ending out sooner is much better than ending out later. Working in small batches ensures that a startup can minimize the expenditure of time, money, and effort that ultimately turns out to have been wasted. Small batches at IMVU. At IMVU, we applied these lessons from manufacturing to the way we work. Normally, new versions of products like ours are released to customers on a monthly, quarterly, or yearly cycle. Take a look at your cell phone. Odds are, it is not the very RST version of its kind. Even innovative companies such as Apple produce a new version of their two flagship phones about once a year. Bundled up in that product release are dozens of new features. At the release of iPhone 4, Apple boasted more than 1,500 changes. Ironically, many high-tech products are manufactured in advanced facilities that follow the latest in lean thinking, including small batches and single-piece 2OW. However, the process that is used to design the product is stuck in the era of mass production. Think of all the changes that are made to a product such as the iPhone. All 1,500 of them are released to customers in one giant batch. Behind the scenes, in the development and design of the product itself, large batches are still the rule. The work that goes into the development of a new product proceeds on a virtual assembly line. Product managers figure out what features are likely to please customers. Product designers then figure out how those features should look and feel. These designs are passed to engineering, which builds something new or modi an existing product, and once this is done, hands it to somebody responsible for verifying that the new product works the way the product managers and designers intended. For a product such as the iPhone, these internal handoffs may happen on a monthly or quarterly basis. Think back one more time to the envelope stew, NG exercise. What is the most efficient way to do this work? At IMVU, we attempted to design, develop, and ship our new features one at a time, taking advantage of the power of small batches. Here's what it looked like. Instead of working in separate departments, engineers and designers would work together side by side on one feature at a time. Whenever that feature was ready to be tested with customers' they immediately would release a new version of the product, which would go live on our website for a relatively small number of people. The team would be able immediately to assess the impact of their work, evaluate its EECT on customers, and decide what to do next. For tiny changes, the whole process might be repeated several times per day. In fact, in the aggregate, IMVU makes about FTY changes to its product, on average, every single day. Just as with the Toyota production system, the key to being able to operate this quickly is to check for defects immediately, thus preventing bigger problems later. For example, we had an extensive set of automated tests that assured that after every change, our product still worked as designed. Let's say an engineer accidentally removed an important feature, such as the checkout button on one of our e-commerce pages. Without this button, customers no longer could buy anything from IMVU. It's as if our business instantly became a hobby. Analogously to the Toyota Accord, IMVU used an elaborate set of defense mechanisms that prevented engineers from accidentally breaking something important. We called this our product's immune system because those automatic protections went beyond checking that the product behaved as expected. We also continuously monitored the health of our business itself so that mistakes were found and removed automatically. Going back to our business to hobby example of the missing checkout button, let's make the problem a little more interesting. Imagine that instead of removing the button altogether, an engineer makes a mistake and changes the button's colors so that it is now white on a white background. From the point of view of automated functional tests, the button is still there and everything is working normally. From the customer's point of view, the button is gone, and so nobody can buy anything. This class of problems is hard to detect solely with automation but is still catastrophic from a business point of view. At IMVU, our immune system is programmed to detect these business consequences and PAGA-ED to detect TSASSCO6CESAD. Automatically invoke our equivalent of the Accord. When our immune system detects a problem, a number of things happen immediately. 1. The defective change is removed immediately and automatically. 2. Everyone on the relevant team is notified of the problem. 3. The team is blocked from introducing any further changes, preventing the problem from being compounded by future mistakes. 4. Until the root cause of the problem is found and exceed. This root cause analysis is discussed in greater detail in Chapter 11. At IMVU, we called this continuous deployment, and even in the fast-moving world of software development it is still considered controversial. Point 3. As the lean startup movement has gained traction, it has come to be embraced by more and more startups, even those that operate mission-critical applications. Among the most cutting-edge examples is Wealthfront, whose pivot was described in Chapter 8. The company practices true continuous deployment, including more than a dozen releases to customers every day in an SEC-regulated environment. Point 4. Continuous deployment beyond software. When I tell this story to people who work in a slower-moving industry, they think I am describing something futuristic. But increasingly, more and more industries are seeing their design process accelerated by the same underlying forces that make this kind of rapid iteration possible in the software industry. There are 3 ways in which this is happening.